Hello there, everyone. My name is Crazy Caleb, and welcome to the long-awaited Rainbow Arrows tutorial. Today we're going to be taking a look at, you guessed it, Rainbow Arrows, and this module has been notoriously for a long time one of the modules that's been, that's someone's wanted to do a tutorial on, but eventually what happened was that it just didn't happen. But now I have successfully learned this module and I've gotten very consistent with it, and now I'm going to teach you how all of the puzzles of this module work. Because this module is very difficult, no question about it. And if we take a look here, if we continue scrolling down, there is a lot of information that we need to go over, and hopefully that we'll be able to go over in these next two examples. I'm only going to be doing two examples because this module is fairly simple. It does look intimidating, but it's actually not as bad as it looks. So let's take a look at it. So first things first, what we need to do here is we need to take a look at what we're looking at here. And in this case, it's going to be a bunch of different colors of arrows. In this case, it's always going to be white, red, orange, yellow, green, blue, purple or indigo in this example, and a pink, or I believe it's referred to as it's indigo and purple, but it's like generally you can do purple and pink. You can do magenta. There is just one step that is going to be relevant to different types of arrows, which we'll get into in just a minute. But essentially what our goal is with this module is we need to figure out the order we're going to be pressing all of these arrows in. And this is going to be based off of, for example, we're going to be using like north, east, southwest, and then northwest, southeast, southwest, and then northwest, northeast. This is exactly what we're going to be basing off these directions based off of, but we're only going to be pressing each button exactly once. That's going to be our goal here. So we're going to use the location of the white arrow to determine our starting rule in the table below. So our starting arrow is currently in the southwest, and we're going to be taking a look at the southwest rule first. So let's find southwest, which is going to be this one right here. So now let's continue on. If the rainbow arrow proceeds clockwise, move down one rule after each press. Otherwise, move up one rule instead, and the table itself wraps around. Now, the way that this works is essentially we're always going to be starting on white, and the one that we want to pay attention for and to determine what the rainbow pattern is which direction from white is red going towards. Red is the beginning of the rainbow, and if you search up rainbow, for example, if you search up rainbow here, it's going to be the first one that pops up, images, if I can find it, is going to be red. Yes, red, orange, yellow, green, blue, and purple. And the pink there is just extras just for the sake of it being a full 8 arrows in this instance. So let's get right into this. But it always will be a white-red. In this case, this one is going to be going clockwise. So we're going to be going down one rule instead of up. That's what we're going to be doing here. So now we're going to start at this rule, and what each of these is going to give us is this is going to give us one arrow to press, which we will be taking a look at in just a second. So, all arrow presses must be unique. If a rule says to press an arrow that has already been pressed, then instead press the closest arrow that has not been pressed yet in either direction. In the case of a tie for distance, use the arrow reached by following the same direction as the rainbow pattern. Pressing an incorrect button will result in a strike and reset all of the inputs up to that point. The number on the display and the colors of the arrows will not change, however. That's going to be one important thing. You will not, it's not a full reset on this module. If you happen to strike somewhere in the middle of the module, it is very likely that you just messed up one step. But just keep in mind that it will not completely reset the entire module. You just need to figure out where you made that mistake from. And one other thing important to note is that the color of the actual number on the module is not relevant. It's not going to be relevant at all. It's just the number that we want to note down, which in this case is going to be 85. So let's take a look. So now let's take a look at our first one here. And we're going to have to go through a series of different rules to get each one button pressed. So remember, we're going to be going, the rainbow pattern is clockwise, and we're going to be going one down each time. That's going to be the way this works. So now let's take a look at our first rule. And this one actually is one of the trickier ones that you will experience. So let's take a look. So for each word in the table to the right, determine a value equal to the count of letters in the word that are present in the serial number, plus the number of modules in the BOM named blank arrows. And what these words represent is that these represent each of the individual different arrow types that were made up until this point. So there's the possibility of there being red arrows, there's the possibility of there being orange arrows, yellow arrows, green arrows, blue arrows, indigo arrows does not exist, purple arrows does exist though, and double. Double is going to be referencing double arrows in this case, which is going to be a speaking evil module, double arrows. There is no indigo arrows, right? Let me just make sure. Yeah, there is indigo cipher, but not indigo arrows. That's the only one that you're not going to experience any sort of word arrows, and that's what this word represents, is these words over here. There we go. So that's going to be what it represents. So we need to determine a value for each of these values here, equal to the count of the letters in the word that is present in the serial number, plus the number of modules on the bomb named blank arrows. In this example, we're not going to be worrying about word arrows because of the fact that we don't have any other arrow modules on this bomb, and rainbow arrows itself is not relevant in this example here. There's no rainbow arrows present, so we don't have to worry about that. But in the meantime, let's also get my serial number because this is very important for a lot of steps here. So let's do Charlie 29, Romeo Lima, and 2. Okay, so let's take a look. Here and let's see what happens. So what we're going to be doing here is we're going to go through each of these individual words and we're going to try and find the highest value and look up the number next to that word in the table. Okay. So now what it wants us to do is it wants us to determine a value equal to the count of the letters in the word that are present in the serial number, the count of the letters in the word that are present in the serial number. So what you want to do is go through each of these letters individually and see if they're actually present in the serial number. In this case, we have R is going to be indeed present, E is not, and D is not. So in this case, we have a value of 1 for red. And one of the things that you can do immediately is you can sort of eyeball it a little bit, and you can see that pretty much the biggest determining factor is going to be that Romeo and that Lima, which in this case, I can already see a couple options here. There is 2 Limas in yellow, and each of these Limas does not the Limas do not count as 1. In this case, there is the possibility of there being duplicate letters. Both of these Limas count as 1 point, giving us a total of 2 in this example. So in this example, this would be 2 for yellow. For purple, there is 1 Romeo and 1 Lima. That's going to count as 2 as well. And as far as I'm seeing, that looks like it's going to be the rest of the examples here. There is an orange and there's an R in Romeo. There's an R in orange, a Romeo and orange. And that looks like that's it for this one. There's no C's present at all. And it looks like it's going to be determined by these 2. And there's no other Limas present. There is double, of course, but that's not going to be, there's no R in there. So now, with this example, there is a tie. In this case, the yellow and the purple, they both have 2. Both have 2 that are present in the serial number. So we're going to be taking the word with the highest value, which in this case we have both of these guys. If there is a tie, however, we're going to be using the word with the lowest number. So we're going to be doing yellow in this case. Yellow is going to be our winner, chicken dinner here. So now, what we're going to do is we're going to take this number, in this case being 3, and now we're going to start from the white arrow and move that amount of steps in the same direction as the rainbow pattern. Then press the arrow in that position. So we're going to start from white. The rainbow pattern is going to be moving clockwise, and we're going to be moving from white. We're going to be moving 3 spaces. So we're going to do 1, 2, 3, up to yellow appropriately, and this is going to be our first button press. Our first button press is going to be north. Now, it's very important for you to actually write these down beforehand because there is going to be the possibility of you landing on the same position that you pressed beforehand, but we want to make sure that we remember that all of the presses have to be unique. But so far, we've done our first one here. This is our first example. So let's move on down, 1 down each rule. So we're going to be moving down to west. Now, this one is also a very tricky one. This one, it's this one, the A, B, C, D, E, F, G, and probably the maze one that looked the most intimidating. But there's also a couple other ones that I want to cover here. So let's take a look. Using the table to the right, find the word that shares the most unique letters in common with the serial number. So now it's unique letters in this example. So what we want to do is you want to take a look at each of the words, and if there is simply just 1 letter present, that means that, and if there happens to be, for example, 2 Limas in the serial number for some reason, if this was a Lima, this would only count as 1 for lower. So just keep that in mind. It's very important to notice the distinction between unique and simply just being present in the serial number. It's very important to note down the differences between these two. We had 2 Limas here that both had a Lima present in the serial number. That counts as 2. And in this example, it was unique. That would only count as 1. But in this example, it's referring to unique. So let's take a look. So using the table on the right, we need to find the word that shares the most unique letters in common with the serial number. This is pretty easy to do. We only have Charlie, Romeo, and Lima. So let's just start searching things up. So do we have any Charlies? Let's Control F. We do have Charlies. Now, we do have a Charlie and a Romeo together. That's a possibility of there being 2. So now let's take a look. Do we have any other counters to A2 in this example? So let's take a look at Lima. Lima, we do have a royal, we do have, and that's going to be it, because there is both the R and the L present. And for R's, what do we have? And we do have a lower, in this case, L and R. So I think that that's going to be it. Yeah. So both of these guys happen to have 2 letters present in the serial number that are unique. Lower has L and R. Farce has R and C. Royal has R and L. So now, what exactly do we do with this? If there are multiple, use the first in reading order. So in this case, lower is going to be our word that we're going to be taking a look at here. Then, take the nth letter in the English alphabet, where n is the displayed number modulo 26 plus 1. So we're going to do 85, in this case, popping out our handy-dandy calculator. 85 modulating this by 26. In this case, I'm going to be subtracting 26 until this number is lower than 26. That's going to give us 7. And then we're going to add 1 to this. And that's going to give us a value of 8. 8 is going to be a hotel. Now what we want to do is we want to take a look at this rule. If one of the words adjacent to the given word, both orthogonally and or diagonally, that starts with that letter, in this case we're looking for the hotel, we're going to press the arrow in that direction. Now, one important thing to note here. This table does not wrap around. So we cannot say that, oh, we have a hotel. From this position, if we were to go bottom left, we would be able to go to hotel. That's not how this works. We're only able to go to one of these 5 squares. That's the way that this works. So we're only limited to these 5 directions. So now, in this example, we don't actually have any hotel words that surround it. Hotel, the option is not available for us. So what exactly do we do with this? We don't have anything that would take us to that word. Otherwise, use the next letter of the English alphabet, wrapping around from Zulu to Alpha if necessary, and repeat until such a word is found. So what we want to do essentially with this example is we want to do from hotel. We want to continue on. So we want to go next up. We would go India. We would go Juliet, and so on and so forth. And essentially, what we want to do is we want to come to the earliest alphabetical position that comes before that, or that comes first, essentially. And in this example, we already have passed A and F. Hotel is way past those guys. So in this case, we have Tango, Whiskey, and Yankee. And Tango is going to be the first one that we end up running into. So we're going to be going to the direction that it takes us to. So we're going to be pressing the arrow in the direction that would take you to this word. And in this case, from lower to Tango, that would be us heading east. So our second direction that we're going to be pressing is east. Okay. Now, this next one is actually very easy. This is probably one of the easiest ones you'll come up with. This is actually the easiest one you'll come across. Take the 2 digits on the screen individually and compare them to the bomb's serial number. If both digits on the module are present, press north. Now, let's take a look immediately. 8 and 5, none of them are present. So we can already skip down to the bottom of this. We have, if neither are present, we're simply going to be pressing south. And in this example, we haven't pressed south so far yet. So south is going to be our third button place. Fairly simple one, and it's quite a nice one to do, in my opinion. So let's take a look at our next one. So we're going to go down, looping back up to the top, and now we're going to go to the maze one. And this one looks very intimidating, and it actually did look intimidating for me a while too. But essentially what we're going to be doing here is we're going to be using the right digit of the display, in this case being 5, as the starting square in the maze, to the right, so it's find 5 right here, and navigate to the square that contains the last digit of the serial number in the fewest amount of moves possible, and the fewest amount of moves required. And in this case, it's a very straightforward path with most of these. So we're going to be going to the last digit of the serial number, which is going to be a 2. Okay, a fairly short path, which is actually quite nice. And now, what we want to do, if those 2 digits are the same, press the diagonal arrow that corresponds to the relative location of the starting square. Now, if we happen to have, for example, a 2 and a 2, if they both happen to be 2 and 2, so this is 82 instead of 85, what would happen here is you would press the diagonal arrow that corresponds to the relative location of the starting square. If both of them happen to be a 2, you would simply be pressing the northeast position, because from the center of the maze, it is currently up in the northeast. Same thing with the 5. If it was 5, 5, northeast, it will always be one of the diagonals, essentially. It's just going to be the one that is in that corner. So, in this example, though, it is not that case, so we're going to be moving on to this next section here. If the first 2 moves were along the same axis, start from the arrow in the direction of the first move. If the first 2 moves were along different axes, start from the diagonal arrow formed by combining the first 2 moves. So, what exactly does this mean? In this case, we start from 5. We start from 5 and we're going towards 2, which in this case we're going to follow this path right here. What happens here is that we're essentially starting from 5 and we're going to go down and left in the maze. And the way that axis works is we have obviously up and down, and then we have right and left. And the way that axis works is essentially the right and left are on the same axis. If we happen to have 2 of the exact same move, in this case being a, if we happen to have, for example, a left-left or a down-down, that would be corresponding to the exact same axes because of the fact that there is, that they just aren't changing. Think of it like a graph. In this case, we have like the up and then the right. They're on different axes. I hope that makes sense. It's pretty straightforward what it asks you to do. But in this example, the first 2 moves that we have is down and left. They are both moving along different axes. So in this case, this one is going to be what we're going to be doing here. Because we start from 5 and we're going to be going down and then left. Both of them work on different axes. Up and down are the exact opposite, but on the same axis. And right and left are doing the opposite patterns, but they are on the exact same axis. These both are on different axes, down and left. So in this case, we're going to be starting from the diagonal arrow that is formed by combining the first 2 moves. In this case, we're going to be starting from southwest. But there's another thing that we have to do with this module. It's not going to be this arrow that we're going to be pressing here. We're going to be pressing something else. From the starting arrow, we're going to move clockwise a number of steps equal to half the number of moves required, rounded down, and press the arrow in that position. And what this means is that we're going to count the amount of moves that we have to take from getting from 5 to 2. In this case, it's going to be 1, 2, 3, 4, 5, 6. So we're going to have 6 moves. We're going to divide this by half. So this is going to be a 3. 6 divided by 2 is going to be 3, just to make sure. 2 is going to be 3, indeed. And now, we're going to round down, of course, which we've already done. There's no need to round here. And press the arrow in that position. So we're going to be starting from this arrow, starting from southwest. And we're going to be moving 3 spaces clockwise. 1, 2, 3. Now, we've run into a bit of a predicament here. We've already hit north. So now what do we do from this? So now, if we happen to, if the rule says to press an arrow that has already been pressed, which in this case is true, then instead press the closest arrow that hasn't been pressed yet in either direction. And in this example, what happens here is that we run into a tie. Both northwest and northeast have not been pressed yet. And in the case of tie for a distance, use the arrow reached by following the same direction as the rainbow pattern. In this case, the rainbow pattern is going clockwise. So from north, we're going to be moving clockwise over to northeast. And that is going to be how this module works. And in this example, what you would happen to do is you would happen to do 1 space, then 2 space, then 3 space, then obviously 4 space, for the way that the closest arrow that has not been pressed yet. Keep that in mind. That's sort of the way that you want to do the comparison. Do 1 space in both directions, do 2 spaces in both directions, do 3 spaces, and so on and so forth. But in this example, we figured out that our direction is going to be northeast. And that is going to be our 4th button press. Let's continue moving on down. Now, this one is a bit weird. Northeast is a bit of a weird one, and it's actually not too bad, but it is a bit weird. So first things first is we're going to be multiplying the displayed number by 4. So 85 times this by 4. By 4, modulating 360. In this case, we don't have to worry about that because it's only going to be 340. So let's mark this down. 340. Now, starting from the exact center of the white arrow, rotate clockwise by that number of degrees, then press the arrow that is closest to that position. However, if this is the 4th or 8th rule used, press the arrow directly opposite that position instead. Very important to keep that in mind. You will do it normally. You'll still do it clockwise. But make sure you press the arrow that is directly opposite that position instead if you happen to be on the 4th rule. The 8th rule itself actually does not matter because of the fact that at that point you've determined 7 button presses and you're already done at that point. So let's take a look then. So we're going to start from the exact center of the white arrow. And we're going to be rotating clockwise by 340 degrees. And this might seem really complicated to you. This actually might seem like a little bit scary. But one of the ways that I like to do this and I like to simplify this is I like to do a bit of simplification. So one of the things that we can do is we can rotate 180 degrees, which is the exact opposite of the module, and in this case, start us off with 160. So we're already at the green position in this dead center here. Now, let's get rid of another 90, which in this case, if you know basic math, 360 divided by 4 is going to be worth 90. And what can happen here is that we can travel 2 different arrows at a time. So it would be 90 degrees, 180 to get over to the green, and then we do another 90, which in this case would take us over to the purple. Now, 340 minus the 180 minus the 90 is going to give us a 70. And now what we want to do is we want to press the arrow that is closest to that position. And in this example, what we can do here is we know that each arrow, the one that has more than 45 degrees, or rather each arrow has to go, each rotation is going to be rotating 45 degrees to get to the center of the next arrow. So we know for a fact that we're going to be starting over on this pink arrow here. Now what we need to do is we need to determine whether we're closest to the pink arrow or the white arrow. And this might seem a little bit trickier, but essentially what we can do is we can take the 45 degrees that it takes to get to rotate over to the center of this white again, and determine the number that we have left, in this case being 25, is that number greater than half? And that's going to be the way that we determine this. So 45 minus the 25 is going to leave us with 20, which in this case is going to be under half. So 25 plus the 20 is going to be the greater of the two halves, which means that we're going to be rotating more into the white arrow section. So this means that we're going to actually be pressing white here. So we're going to be pressing southwest for this one. It's a bit of a weird way of doing it, but essentially what you want to do is you want to figure out which one you're going to be closer towards. And in this example, you're going to be closer towards the white arrow. There is always going to be some way to determine which one you're closer to, because if you happen to get into the center, because 45 divided by 2 exactly is going to result in a 22.5. If your number, in this case, if your number was over 22, it would be greater, so it would be moving over to the white. And if your number was less, it would still be in the pink section. That's the way that this works. Hopefully that makes sense. It's a bit of a weird instruction to give, and I'm sorry if I explained this improperly, but that's essentially one of the ways that you're going to be determining this rule. It's a bit of a weird one to see. But anyways, we've determined that our arrow is going to be southwest since we were closer to the white arrow than the pink arrow, and that's going to be how we're going to move on. And remember, this is not the 4th or 8th rule, so we're not going to be pressing the arrow that is directly opposite this position. We're not going to be pressing northeast, so we don't have to worry about that. Next up, east. East is another tricky one. All of these rules are relatively tricky to do. They can get you up. And essentially what we're going to be doing here is we're going to be assembling a 4-bit binary. For those of you who are familiar with binary, it's very straightforward. It's simply to the power of 2. I'm not going to teach you binary in this tutorial. I'm just simply going to teach you how this module works and what's going to be happening here. So the way that you want to do this, and remember, because this is from least to most significant, so what's going to be happening here is that you're essentially going to be given bit 4, bit 3, bit 2, and bit 1. And this is going to be from least to most significant. So this is actually, if you go from top to bottom, it's going to be giving it to you backwards. So in this case, you want to go from bit 4 up to bit 1. That's going to be the way that this works. So let's take a look. So bit 4 is going to be equal to 1. Bit 4 is going to be 1 if there are at least as many battery holders as there are port plates. So do we have at least as many battery holders as there are port plates? There are 2 port plates and there's only 1 battery holder. So there is not greater than or equal to battery holders than there are port plates. So this is going to be marked with a 0. Next up, bit 3 is 1 if the displayed number is a multiple of the number of batteries plus 1. In this case, we only have 1 battery present on the bottom, so the number of batteries plus 1 is going to be 2. And in this example, this one's actually really easy to do. The displayed number is not a multiple of 2 because of the fact that it's odd. It's just not going to work. So that's going to be another 0. Okay? Bit 2 is 1 if either a parallel port or a serial port is present. In this example, we do have a parallel port present, so that's going to be marked with a 1. And then finally, bit 1 is 1 if any diagonal direction has been pressed before this point. And at this point, this is true. We have pressed both northeast and southwest. Both of these count as diagonals. That is going to be equal to a 1. So now, we're not done with this yet. We're not done with this binary string quite yet. Don't convert this into base 10, or a decimal number in this case. We're going to be rotating the resulting binary number to the right by the number of indicators, then convert it to a decimal number. So the number of indicators that we have is currently going to be 2. So let's remove these 2 ones over to the right. Let's shift it right over to the beginning over on the left side. And this is now what we're going to convert into decimal. And this is simply going to just be 8 plus 4 if I can type here, is going to be worth a 12. And now what we're going to do here is move clockwise that many steps starting from north and press the arrow in that position. We're going to be starting up here. we're going to be moving 12 clockwise. Now, one of the things that we can also do here is we can simply just modulo this by 8. We don't need to do a full 12 rotations, and this is simply just going to give us 4 again. So now, starting from north, we're going to be moving clockwise 4 steps. So 1, 2, 3, 4, down to south. However, we have already pressed south so far. So now what we want to do is we want to take a look and let's see which one is closest from south that we have not pressed yet. And in this example, this is going to be southeast. We've already pressed the southwest. We have not pressed southeast yet. So this is going to be the closest one. Because as it says here, if a rule says to press an arrow that has already been pressed, then instead press the closest arrow that has not been pressed yet in either direction. And there is no tie for this distance, so we don't have to worry about that. Now, let's do one last rule, because all we simply need to do is we need to simply determine one more arrow, and then we know for a fact that the one that is missing is going to be the last one that we're going to be pressing. So let's take a look at this one. So if this is the starting rule to press the white arrow, in this case, southeast is a bit of a unicorn case. If you happen to get the starting rule, we would simply press the white arrow. However, it is not in this case. So otherwise, starting from the last arrow that we pressed, in this case, we're going to be starting at southeast. We're going to move counterclockwise until an arrow that has not been pressed is reached. So moving counterclockwise from southeast, we have pressed east, we have pressed northeast, we have pressed north. We have not pressed northwest. Northwest is going to be where we're beginning. We're not pressing this arrow quite yet, though. Because now, what we're going to do is we're going to then move clockwise a number of steps equal to the number of arrows pressed thus far, and press the arrow in that position. So from northwest, the amount of arrows that we've pressed in this case is going to be represented by 6. We have 1, 2, 3, 4, 5, 6. So from this, we're going to be going 1, 2, 3, 4, 5, 6. Now we've already pressed southwest beforehand. So what we're going to be doing here is we're going to be comparing south and west. We have pressed south. We have not pressed west. So west is going to be our next press. And then finally, based off of the process of elimination, northwest is going to be our last direction. Each of these directions are unique. Each of these directions are being pressed exactly once. And that's just the way that we need to do it. So let's press these buttons and get this into the module, and hopefully we've solved this thing. So we'll do north, east, south, northeast, southwest, southeast, west, and then finally to finish this off, northwest. The arrows, the module will start flipping out, and it will say GG. We'll go over one more example, but as you can see, that is the way that this module works. Now, hopefully we will be able to get this last rule, south. This one is a little bit interesting rule, and it actually is quite easy to mess up too. This is definitely one of the harder ones too. But that's the way that this module works. Let's go into one more example, and let's hopefully see what we can get here. But as you just saw what happens right there, is I did not receive any strikes as I was pressing any of the arrows. That means that if you happen to press a wrong arrow, if you happen to press a wrong arrow throughout the entire sequence, it will immediately let you know if you struck. Because as you can see, pressing an incorrect arrow will result in a strike and reset all of the inputs up to that point. So that's what happens. We were able to figure out that, hey, all of my presses went in perfectly. That means we were good to go. So let's take a look at one final example, and we can get this show on the road. And I will go through this a little bit faster, except for the south rule, just because I want to be able to explain this rule efficiently. And hopefully I will be able to teach this in a bit of a better way. So let's see what we get. Okay, so we're going to be starting on east. So we're going to be starting on east here, because that's where the white arrow is. And then the rainbow pattern is going to be moving clockwise again. So we're going to be moving down one more time. So east, clockwise, and we're going to move one down again. Perfect. Similar to last time, and then we have a number of 59, by the way. 59. I don't even need to really note down east. So we have a serial number of Echo Mike 9. Victor Whiskey 2, okay, and let's take a look. So we have 59 here, so let's take a look and see what we start with. So east is the binary here, so let's figure out what we need to do for this one. Bid 4, if there are at least as many battery holders as there are port plates. Battery holders as there are port plates? Yes, this is true. There are 2 battery holders and there are 2 port plates present. There is at least as many battery holders as there are port plates. This will be true if the battery holders is the exact same amount as the port plates, or if the battery holders is greater than the amount of port plates. In this case, they're both the exact same. This is going to be a 1. If the displayed number is a multiple of number of batteries plus 1, in this case we have 3 batteries, so plus 1 is going to be a 4. 59 in this case is not a multiple of 4. Very simple. 60 is a multiple of 4, not not for 50. So that's going to be a 0 for this one. Next up, bit 2 is 1 if either a parallel or serial is present on the BOM. In this example, no. We have RCA, RJ, DVI, and PS2, not parallel or serial. So it's going to be marked with a 0. And bit 1 is 0 if any diagonal direction has been pressed before this point. In this example, no. This is actually going to be the first rule that we come upon, so this is actually not going to be true, so 0. So now, let's rotate the resulting binary number to the right by the number of indicators. The indicators that we have is currently going to be a 1, so this is going to be shifting this 0 over to the right by 1. We're going to now convert this into a decimal number. In this example, this is a 4. And what we're going to do is we're going to move clockwise that many steps, starting from north, and press the arrow in that position. So moving clockwise 4 times, 1, 2, 3, 4, and that's going to be our starting direction of south. That's going to be our first button. Now keep in mind that when it tells you to start at a specific direction, what it wants you to do is not count this one. It wants you to start from the next one. So in this case, northeast would be the first one that you would count. 2, 3, 4. Hopefully that makes sense. Now let's move on to the next one. So from southeast, we're going to be, this is not our starting rule, unfortunately. Otherwise, the starting arrow, starting from the last arrow that was pressed, in this case being south, move counterclockwise until an arrow that has not been pressed is reached. In this example, if we move counterclockwise, we go to our first one, which is a southeast. We're not going to be pressing this quite yet, because now we're going to move clockwise the number of steps equal to the number of arrows pressed thus far, and press the arrow in that position. However, we only moved one space counterclockwise from southwest, and we've only pressed one button at this point, which in this case would take us back to south. So we're actually going to get into a tie here. So we haven't pressed southwest or southeast, and in this example we have to do the tie distance. So use the arrow that's going to be following the direction of the rainbow pattern, which in this case, white, red, in this case will be clockwise. We're going to be taking a look at, we're going to be pressing southwest in this example. So let's go to the next rule. Now for this one, assign every arrow a letter from A through H, starting with the white arrow and moving clockwise. So we're going to have white, red, orange, yellow, green, blue, purple, and magenta. And we're going to be assigning each of these characters A through H. So A, B, C, D, E, F, G, H. Okay. Now what we're going to do is we're going to modify this string in some ways. So we're going to move any letters present in the serial number to the front of the string. We do have echo, and that's going to be 8. So all we have to do is move echo to the front of the string. So echo in green. It's very important that you keep the letters and the colors that they were assigned to in the exact same positions as they are. It's very important to do that. So we've already done that. If the last digit of the serial number is even, in this case that is true. We're going to cycle the string to the right by the first digit of the serial number, which in this case is going to be corresponding to 9. Now, we only have 8 characters present in this actual string, so what this means is that we're going to be doing simply a shift of 8 and then a shift of 1. So we're going to only shift these guys to the right by 1. So Hotel and Mike are going to be shifted to the right by 1. Perfect. If the number of batteries is odd, move all letters in odd positions to the front of the string, keeping them in the order that they appear. In this example, yes, there is odd amount of batteries. In this case, we have 3 batteries present. So what we're going to do is we're going to move all letters in the odd positions to the front of the string. And this is based off of this current position. So 1, 3, 5, and 7. These are what's going to be moved forward. So we have Hotel Alpha, Charlie Foxtrot, magenta, white, orange, blue. We're going to move that to the front of the string, and then what's going to happen here is that we're going to do the evens in the exact same position as they were originally ordered, but they're going to be the second half of the string. So Echo, Bravo, Delta, Golf, and then we have green, red, yellow, and purple. And this is going to be the new string. Okay? Then finally, if north or south has been assigned a vowel, reverse the string. So now, does purple or orange have a vowel assigned to it? Purple is assigned to Golf, not true. And then orange is assigned to Charlie, also not true. So in this example, that is not true. So now we're done with those steps. Afterwards, press the arrow that the nth letter of the string was assigned to, where n is the digital root of the displayed number minus 1. So we're going to do the digital root, which in this case is we take the displayed digit here, and what we're essentially going to do is we're going to add up all the digits until we're left with 1 digit left. So we're going to do 5 plus 9, which is going to give us 14, and then we're going to do 1 plus 4. Which is going to give us 5, minus 1, which is going to give us a 4. So now we're going to take a look at the 4th string, and if n happens to be 0 or less, we're going to use 1 in this example. So now let's take a look. So we're going to take a look at the 4th position in the string, which in this case is going to correspond to Foxtrot or Blue. We haven't pressed northwest, and this is going to be what we're going to be pressing for this stage, northwest. And that is that rule. It's not too bad. It's just very easy to mix up some of these rules. It's very important that you make sure that you pay attention to odd positions and make sure that you reorder them correctly. But that is essentially that rule. Now let's go back into some of these rules that we've done beforehand. So let's go southwest. For each word in the table to the right, determine a value equal to the count of the letters in the word that are present in the serial number. In this example, we have quite a few E's. That's going to be what we're going to be paying attention to, as well as M's. I don't think there's any M's though. And remember on bigger bombs, keep in mind of the arrows, the arrow variants: red, orange, yellow, green, blue, purple, and double. Keep those in mind, because those can get you, and it is very easy to mess up. But just make sure that you keep that in the back of your mind. I don't think there's any victors as well, so I believe it is solely going to be determined on the echoes here, as well as there's no whiskeys. There is a whiskey technically. So what we want to do here is we want to count the amount of echoes in each of these words here. So we have quite a few of them. Now, the kicker here is that green has 2 echoes present in them, and this is going to be the exact same thing we did for yellow in the previous example. Both of these E's are going to count as 1, even though there's 2 of them in this name. They're both present in the serial number, so that's going to be counting as 2 for green. However, yellow also has 2, and that's going to be represented by the echo and the whiskey. And this is going to be a tie for the values here, because of the fact that if there's a tie, we're going to use the word with the lowest value, and in this example, we're going to be using yellow. So we're going to be doing 3. I believe this was the exact same thing we got beforehand, but just keep in mind that if there happens to be an E, green is going to be one of the things that you need to pay attention to, because most of these happen to have an echo in them. However, green has 2 of them. Keep that in mind. So yellow is going to be the word that we use. We get the number from that vowel. We get the number from that from this one, which in this case corresponds to 3. And then what we're going to do is we're going to start from the white arrow and move that number of steps in the same direction as the rainbow pattern. The rainbow pattern is moving clockwise, so we're going to be pressing, we're going to be moving 3 in that clockwise direction. 1, 2, 3, over to southwest. We have pressed southwest. We have pressed south. We have not pressed west. Therefore, west is going to be our 4th position here. Okay. Next up, we're going to be taking a look at this one, the word one again. Using the table on the right, find the word that shares the most unique letters in common with the serial number. This is going to be an interesting one, because all of these letters are unique, and we have a couple interesting characters here. Do we have any mic? We do have a mic, but that's going to be just 1. We want something else. Victors, we have a couple of those. Bravo, no, that's a 1-1. I believe there might be something that has 2 of them. M-E, no, we just did E. E, do we have any W's? That's what I'm mainly concerned about. Yes, here we go. W. W is going to be the one that we determine here. Okay, both white and lower happen to have a W and an echo in them, so that means that this is going to be a tie. So we're going to be using the first in reading order, which is going to be corresponding to white. And now what we need to do is we need to determine which direction we go in one of these 5 directions. Let's figure this out. So we're going to take the nth letter of the English alphabet, where n is the displayed number modulo 26 plus 1, so 59. Modulo this by 26 plus 1 is going to be hotel again, ironically enough, so that's going to be 8. Now, from hotel, we don't have that present. We don't have that option available to us. Hotel is over here, which is not present in one of the adjacent spots. The next available one that is going to be available to us is going to be lower, because of the fact that we're going to have H, I, J, K. We don't run into any of those yet, and then L. L comes before M, and then M comes before P, P comes before T, and then Y, and then T comes before Y. Lower is going to be the one that we run into first, so this means that we're going to be going in the southwest direction. However, once again, we've pressed the southwest direction. So now what we need to do is we need to do the case where that's going to be closest to this position. But we've already pressed west and south. We've already pressed northwest. We have not pressed southeast. Southeast is going to be the arrow that we pressed. This is where the whole one in each direction, then 2 in each direction comes into play here. So our direction for this one is going to be southeast. Perfect. Next up, the easy one. 5 and 9. 9 is present in the serial number. Take the 2 strings on one individually and compare them to the bottom serial number. The right digit is present in the serial number. If only the right digit is present, we're going to be pressing east for this one. A very simple one. East has been pressed. Perfect. And now for our last rule, we're going to be taking a look at the maze here. So we're simply going to be skipping the northeast direction because it's the last one that we wouldn't run into. So let's take a look. So use the right digit on the display, in this case being 9, and we're going to be using the last digit of the serial number to get the ending point, which is going to be A2. This is going to be a much longer maze, definitely. Now what we want to do here is we actually have a couple possibilities to which we can navigate this maze from. We can go this way, or we can go up here and then hit this. And from what I'm seeing already, this way is going to be shorter. The two ups, the two rights, the two ups, it's already looking a lot shorter than having to go right, up, right, left. Yeah. So this is going to be the shortest path that we have to take. It's important to make sure that you happen to get the shortest path, because there is the possibility of there being multiple paths that you can take, but it wants the fewest number of moves required. Simple as that. Let's get rid of this hotel, by the way. Now, this is where these first two moves happen to go along the same axis. Because we have two up movements. We're going to start from the arrow in that direction of the first move. We're going to start from north in this example here. And now, let's count the number of moves that we require to get from 9 to 2 in the shortest way possible. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24, we're going to have this number. So 24 divided by 2 is going to be 12. And now what we're going to do, from the arrow that we got previously, we're going to start from north, and we're going to be counting 12 times around the clock. So let's do 1, 2, 3, 4, 5, 6, 7, 8. And as you can see, we reach 8. We can just simply modulate this number by 8 because we reach north again. So this is just simply going to be 4. 1, 2, 3, 4. We've already done south. We've already done southwest and southeast. We've already done west and east. We've already done northwest. We have not done northeast. This is going to be the one that we press right here. Northeast. And then finally, to end it off, north. So this is going to be our arrow sequence that we're going to be pressing here. And just like that, we will hopefully be able to solve this module. So south, southwest, northwest, west, southeast, east, northeast, and finishing it off, north. And just like that is a solved module. As always, thank you guys for watching. I'm sorry I took so long to get around to this tutorial. This one is definitely one that I'm really kicking myself. This one was made, I kid you not, Rainbow Arrows, 2019. It is one of the oldest modules that does not have a tutorial up to this point, and now it finally does. So thank you guys for your patience, and I'm so sorry I didn't get around to this sooner. It was part of my laziness and part of me just being a scared little idiot that I didn't do this for so long. So thankfully, I've gotten it done now. Hopefully you guys understood this, and if you have any questions, please let me know in the comments below. As always, stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.